Right, let's begin. So we're going to continue from what we have discussed on Monday, which is on list. So we have learned new things about list. Before this, we learned that list is a container of objects. It can contain more than one type of objects. And elements in the list can be addressed by its index, where index starts from 0 if you count from left to right. You can also count from right to left, then index starts from -1. Okay, so in particular, if you want to retrieve the last index, you can just use L square bracket -1. Okay, now we also learned long time back that the length of the quiz represents the number of elements in the list. And on Monday, we learned how to get the sublist using slicing. That is, we have, just to a very quick recap, we have two values here, start and stop. And then by default, step is equals to 1. And in this course, we're talking about step equals to 1 all the time. And the idea is that you want to take some elements of the list to form a sublist. All right. So starting from the start index, you take the element and you continue to take the next index until you reach stop, where you don't take the element at the index stop itself. Okay. And that's called slicing. And subsequently, you have learned one of the use case of using slicing is that, for example, we want the first half of the quiz, then we take quiz starting from 0. By default, if you don't provide the value of the start value, the index will be start from 0 all the way to index, but not including 6. Okay, so it will start to take elements starting from index 0 all the way to 5. All right, and that will give you the first half quiz. And if you want to take the second half quiz, so the second half, the second 6 quizzes, then you take quiz. All right, you're starting from index 6 all the way towards the end. Now the end value will be the length of the quiz, means the last index. Okay. Now we have also learned that besides when you create a list, all right, you can retrieve the elements of this list using index. You can also update the elements at a certain index. And this is done by easily produce it by using assignment. That is, if you want to change the element at index 1 of the list quiz, you just make it equals to 5. All right, so you basically assign a new value to the element at index 1 of quiz. And we have also learned that if you use slicing without providing any start and end, that means it's going to take every element from 0 all the way to the end. Essentially, it's the same as creating a new list, which is a duplicated copy of that list. Okay. Now, and I also mentioned that before, that this is the right way to create a duplicate copy if you want a new list itself. Okay. However, if you just do quiz copy equals to quiz, this is not creating a new list. You just create a new variable that refer to the same list. All right. So you will see these differences and play around with it in the lab for this week. Now, today I'm going to look at a couple of methods here. Sorted versus sort. Okay, so we're going to use sort, for example, when we want to find the best 10 scores out of 12 quizzes. All right, so this is done. So this is presented in the lab for this week. I'm just going to briefly give you the idea. Suppose, so you know that we have 12 quizzes and the best 10 scores contribute to your final score. Okay, so how do we get these 10 best scores here? So suppose these are your quiz score. Okay, starting from quiz 0 all the way to quiz 11. So in total 12 quizzes. Okay, I want to get the best 10 score out of this. So first of all, you can't just say max of quiz. Okay, so max of quiz will just give you one value, which is the maximum of the quiz score that you get out of all these 12 quizzes. Okay, so we want to get the best 10. So what is the next value? So we wanted a way to rearrange the element in the quiz so that we get the best 10 scores or rearrange them so that it started from the lower score to the higher scores or the higher score to lower score. So the idea is that we sort the list. So either from the lower score to the higher score. Okay, so suppose we sorted in ascending order. That means starting from lower score to higher score. Okay, so the lower score you get is at the first index, and the higher score is at the last index. Okay, then the best 10 scores out of these 12 quizzes will be the last 10 elements. All right, it's because you sorted from lowest to highest. So the best 10 will be the last 10 elements because those are the highest scores. Okay, now if we sort it in descending order, on the other hand, suppose we sort it in descending order, which means from the highest scores to the lower scores. All right, then the 10 best score out of 12 quizzes will be the first 10 elements. All right, so because the highest one, you put it at first at your index 0, and then the lowest one at the last index. So if you want to retrieve the best 10 scores, those will be the first 10 elements of the sorted quiz. Okay, so the idea to find the best 10 score out of these 12 quizzes is to sort the elements in the quiz. Okay, and then we come back to this. How do we sort it? Okay, there are already built-in methods, okay, to sort the list. So if you do help list.sort, for example, so you can see it sort the list in ascending order and return none. So remember for list, okay, you can change the element in the list. All right, and we call it mutations. When you mutate a list, you change the element in the list. And there are methods that change it in place, or there are methods that don't change it in place. They keep the original list as it is, but create a new copy with the changes reflected in the new copy. So when you have return none, usually it means it changed it in place. That is, it modified the list itself. Okay, it didn't create a new list, but it modified the list as it is. So let's look at this, for example. We have this quiz here, all right? And we have quiz.sort. When I execute it, nothing is being returned. There is nothing being displayed here because it's returned none, all right? But things have been changed, all right? Elements inside the quiz has already been arranged. To see the effect, we're gonna type quiz again. As you can see, original quiz is this. Now, after you execute quiz.sort, so operations are done behind the scenes, and it has rearranged the element in quiz. So now the element in quiz is now this. It's sorted in ascending order from lowest to the highest. All right. Now, what is the disadvantage of doing that is that when you rearrange the element in quiz, so for our cases, if you want to find the best 10 scores, we look at the last 10 elements. All right, you can get the best 10 scores using the slicing method that we have seen. You starting from index 2 all the way to the end. That will be taking the sublist of the last 10 scores. Okay, now all of this will be you will have a chance to do it in the lab. But the downside is that now, because you rearrange elements in this list itself, if you want to say, I make a mistake in your quiz 0, it should be 3. But I can't change it anymore because my quiz 0 is not exactly the quiz score that you get in quiz 0. I can't change it anymore because now my quiz 0 is 2.5. It reflects the lowest score in all the 12 quizzes here. Okay, so what we lost is that the previous quiz that reflected score for each intake has already been arranged. So your quiz 0 does not mean it is the score for quiz 0 at all. Okay, so what we lost is that which quiz corresponds to which quiz now after you sorted it, after you sort this in place. Now then we think, okay, suppose I want to keep the original quiz, but I also want the elements in quiz sorted because I need to find out the best 10 scores. So how do we do it? So of course, we want to create a new list, all right, which is a duplicate copy of this quiz, and then sort this copy, okay? So for example, we can create a copy of this quiz copy, and then I create a copy, not by using equals to quiz. Remember, if you say quiz copy equals to quiz, you are still referring to the same object, but we want a duplicated copy, a real duplicated copy, okay? So now these will be two copies. Quiz is one list, quiz copy is another list. All right. So if I now do quiz copy dot sort, okay, and I run it, okay, nothing happens because it's sort in place, but it's sort in place on quiz copy, not on quiz, which means if you print quiz itself now, nothing changed. We still have an original copy where quiz 0 reflect the index 0 reflect the score of quiz 0 itself. And then let's look at quiz copy now. Now this is the one that we sort in place. And now we have the elements in quiz sorted in ascending order. So we have two quiz now. One represents the score for each quiz arranged in terms of index. And the second copy, where it is sorted elements of quiz itself, for which we can use to find the best 10 score out of the 12 quizzes. Okay, so this is how we're going to do it by by keeping the original quiz intact, so that if we want to change quiz 0, for example, to 4, we can use quiz 0 itself. All right, and quiz copy will be the sorted copy of quiz. Anything that is changed here is just a sorted elements of quizzes. Okay. Now, there is creating a new copy and then sort it in place can be done also by just using a method called sorted. Okay, so let's put them in one thing here. Okay. So all of this can be shortened using the function called sorted. It's a built-in function. All right, it returns a new list containing all items in ascending order. So sorted don't sort in place. It basically doing what we are doing here. It create a new copy and it sort this copy and then return this copy to you. So sorted is basically, so if essentially you can shorten your code in this way. So suppose this is your quiz, you want to create a sorted copy. Okay, so you just do sorted and then quiz. All right, so essentially this function here will create a new list with the duplicated copy, which is a duplicated copy, and sorted the elements. And this new list here will be assigned the variable quiz sorted copy. Okay, so you can, for example, print these two out and you will see that they all is the same as what we have here. Okay, so sorted is just a functions that encapsulate what we have done here. Okay, it creates a new copy where every element is sorted. And again, the quiz stay intact. The original quiz list stay intact. Okay, and you will have a chance to play around with it in the lab to find the past 10 scores using what we have discussed here. Now we're going to look at some other methods concerning list, how and index. So these are something that you have already learned. So we just do a very brief recap. So suppose this is my quiz scores. All right. So if I want to know how many of them are perfect score, and the perfect score is 5. So what we're going to do is that we can use 5. You can use dot count, which is a method that count the number of elements with that value. So list dot count. Okay. So it takes a value and return the number of occurrence of this value. So suppose we wanted to know how many of these quizzes are perfect score. So you do quiz.count 5. Okay, so this will return the number of quizzes with value 5. Okay, so of course you can be more meaningful when you write the messages. For example, you say out of this number of quizzes, okay, how many of them are perfect score? Okay. Of course, you use dot format that you have learned. So this will be the length of quiz. And the second one will be quiz.count 5. Incomplete input. Let's see. missing one. All right, so out of 11 quizzes, it said when you do dot count 5 here, it count how many elements in this quiz, in this list here are of elements 5. So we say 1 here, 2 here, 3 here, 4 here. So 4 of them are of perfect score, which is of score 5. Now, the same thing, if I want to know which quiz score is 0, for example, now in this case, for example, I want to know which one is 0, you can use L.index. Okay, so this is just a quick recap of what we have learned earlier on. So do help list.index. You say that you take a value and return the first index of the value. Okay, so in this case, if you look at our list here, I want to know which one that I scored 0. So manually, you will see that this is of index 1. All right, 0 occur at index 1 because we start counting from 0 here. So this is quiz 0, this is quiz 1. So quiz 1 is 0. And how do we know that quiz 1 is 0? You do quiz, which is the name of the list, index, and the value that you are looking for. Okay, so suppose the value you are looking for is 0. Okay, so it will give you the index of 0 in this list here, which is 1. So you can, of course, write down a meaningful message when you print it out. Okay, so quiz 1 is of score 0. Format. Quiz 1 is of score 0. So this is just an example of how to use .count and .index, which we have seen many times in our previous examples. Okay. Now, the downside of using .index is that it's only return the first index. So what if there are many 0 quiz in the quiz list itself, and I want to know all of them? Okay, I don't want to just know one of them. I don't want to just know the first index. I want to know all the indices for which the score is 0. All the quiz number where the score is 0. So we have done this before, which we have learned using for loop. Okay, so this can be done using for loop to iterate the list, the quiz, iterate quiz. This is okay. Remember, we are looking for the indices. So now instead of iterating through the elements in the quiz, we're gonna iterate through the indices. So for I in range length of quiz, so this by now you should something that is second nature to you. If you want to iterate over the indices of the list, this is how you do it. It's very simple, should be something second nature to you by now after we have done so many exercises. All right, for each of them, okay, we're gonna access quiz I. Okay, quiz I will be the value of quiz at index I. Okay, so if it is equals to 0, okay, we are looking for those that are of score 0, then you print, for example, that quiz I is 0. Dot format I. Okay, so that correspond index has value 0 and you are interested in the index. Okay, so let's run this. You will see that quiz 1 is 0, quiz 4 is 0, and quiz 6 is 0. So in this case, we don't use a built-in method because built-in method .index only return one of them, which is the first one. And now you're gonna repeat, basically iterate every indices, not just the first one, every indices, and check which one is equal to 0. And those that are equal to 0, you print it out. Okay. Now, these are all recap from before. Now, we're going to learn some of the new methods that we have not seen, which is to add elements into the list. Okay, so append, let's check it out, is a method. Is a method that appends a new object to the end of the list. Okay, append means you want to add new things to the end of the list, you use append. Let's look at the example. Say L equals to, or I can use the previous quiz, for example. So suppose I have this quiz equals to this, and they are currently, say, 11 quizzes. Okay, suppose we're going to have 12 quizzes instead, okay? And towards the end, we have one more week and we say we're going to do one more quiz. We're going to add one more quiz in there. So suppose we want to append the quiz score. So suppose there is one more quiz. Okay, the last quiz score is 4. Okay, so you're going to append. So we add score of 4 to the end of the list quiz. Okay, suppose I have new quiz and I let you take it. I get your score. Suppose you get 4. Okay, I'm going to add it here. Now, in this case, what I'm going to do is to quiz.append. Append the value that you want. So whatever value that you want to add to the end. In this case, it's a score 4. So I do quiz.append 4. As you can see, after you run it, there is no output. What does it mean? It means it done in place again. So value of 4 is added in place. So there will be no output, but it's already added into the list. So if you want to see it happen, to see the output, you print quiz and you will see that this is the original quiz, which ends with 3. Now it ends with 4. We add one additional value, which is 4, after you do quiz.append 4 to the value of quiz now. Okay, so now quiz, you print length of quiz. You just display a length of quiz from 11 now become 12 because you add one element in there. Now, this is how append is done in place. Okay, you change the length of the quiz, you add one element in there. Now, if you don't want to change the original quiz, rather you want to create another copy where the last elements is added to the copy, but not to the original copy. We can use concatenate, okay? So what is concatenate? You have learned it before. If you want to add 2 lists or 2 strings, you use plus, okay? So use the operator plus to concatenate, which also means combine 2 lists, okay? So for example, if this is your original quiz, okay? Now you want to create another copy. So quiz copy extra, okay? So suppose I give you additional quiz, so from 11 to 12, for example, and I wasn't sure because the last quiz is hard, students didn't get good answer, good score. So I thought, okay, maybe we stick to the original plan to just take 11 quizzes rather than 12 quizzes. But in order to make a comparison, I'm going to create a second copy first, okay? And this copy will have original 11 scores of quiz. And I also have the additional score, which is the last quiz score. In this case, I'm going to create a new list, okay? So remember, it combine 2 lists. You can't just add an element. You have to add a list. So add it, remember, plus, you usually do it with 2 objects of the same type, okay? So remember, for example, 3 plus 3 is equal to 6. But if you do 3 plus 8, it will give you an error. It's a type error. Now, the same thing here, if you want to use plus, I need to make sure both of them are the same type. This here is of type list. So the second one must be of type list as well. What usually students make is always do quiz plus 4. This is not what we want. If you want to add, okay, so we're going to create a new copy of quiz with 4 added to the end. Okay, we're going to be 4, but we must make sure it is a list. Okay, now in this case, we create a new copy of the quiz with the extra value 4 at the end. So let's, for example, print out quiz copy extra. And you will see that 4 is towards the end. And if you want to print out the original copy, this is the original copy. It's not done in place. The original copy quiz is still stay intact. And we have one extra copy with the value 4 added to it. Okay. Now, this is called concatenate, where you add 2 lists. emphasis on list. You can't add a number. You must add a list, okay? Here, when you append a value. What you want to add into the list, the same list that you are talking about, okay? Now, let's look at another method called remove, okay? Remove, say we want to remove some elements from the list, okay? Then we start looking, is there a built-in method for this? If we want to remove, for example, 1 from this, okay? Not 1, suppose. So suppose I want to remove, so for example, suppose I want to remove 0 from quiz. So suppose when I want to calculate the average quiz score, but I don't want to calculate those that are 0, or I just want to remove zeros because those are probably students didn't take it, etc. So I want to remove all the 0 from quiz, okay? So I look at the help functions to look at all the possible methods. One of them is called list.remove, and I look at it, it say that it will take one value and it will remove the first occurrence of the value, emphasis on first, okay? And second thing, it will raise an error if the value is not present. Okay, so there are two information here. To use list.remove, okay, first it will remove only 1, which is the first. Second, if the value that you want to remove is actually not inside the list, it will raise an error. Okay, so let's give a example here. Say we have this is a quiz here. Suppose I do quiz.remove 0. I want to remove 0 from the quiz. Again, when you execute it, if there is nothing output, that means it's done in place. Okay, so let's see. Let's print quiz now. It remove this part. This is the first occurrence. So from 5, 0, 3.5 all the way, now it becomes 5, 3.5. It removed the first occurrence of 0 in quiz. Okay, and subsequent occurrence of 0 still stay intact. If we still have a 0 here, we still have a 0 here. Okay, now let's try to remove something that is not in the list. Okay, if I remove, say, -1, okay, see, this is what's gonna happen. We get value error. It say that it's not in the list. Okay, so when you want to use remove and you don't want a value error, so think again, what would you do? Okay, so if you don't want, so a remark using .remove will raise error if the value for the method is not in the list. Okay, so if you want to handle this case, there are multiple ways to do it. One way that we have learned so far is to use, we use if and else. Okay, so for example, you have learned that to check whether it is in the list before you remove. Okay, so if -1, so say value to remove. Okay, value to remove, say, equals to -1. So if value to remove is in the list called quiz, okay, then we safely execute quiz.remove value to remove. Okay, else if value to remove is not in quiz, if we execute quiz.remove value to remove, it will give me value error. So what I'm going to do is that I'm going to display to the user that the value does not exist. Okay, you can say value to remove, for example, does not exist in quiz. Right? So here, for example, suppose I want to remove -1. In order to avoid value error, I run an if-else statement. If it's in the quiz, it will be removed. If it's not in the quiz, it's going to tell me that -1 does not exist in quiz. Okay, this is how you have what you have learned so far using if and else to avoid error. So when you use a built-in method, so read carefully what are the things that are available to you. Could it be an error if it's not inside? And what are being returned? Is it the first or all occurrence of value? Now, suppose that we want to remove all occurrences of an element from a list, not just the first occurrence. then we can't just use L dot remove 0. Say if we want 0 is the one that we want to remove, because L dot remove zeros will only remove the first occurrence of 0 in the list that we are looking at. So if 0, which is the value that we want to remove, occur n times in the list L, then we need to execute L dot remove 0 n times. Okay, so here, for example, suppose this is my quiz here. Okay, I'm going to change this value a little bit. Now I'm going to count how many times 0 occur. In this case, 0 occur 4 times. 1, 2, 3, 4. Okay, so I will need to execute quiz.remove 4 times. Okay. These will remove the first occurrence, and then subsequently they will remove first occurrence of the list that has already 1 0 removed, and then subsequently the third 0, the fourth 0. So in the end, we will get a list of quiz where all the zeros has been removed. Okay, now we don't want to explicitly write down quiz.remove 0 this number of times. We're going to run a for loop. Okay, so suppose the value that we want to remove is equals to 0. Okay, and we assign a variable called value to remove, and we do a quiz.count on value to remove to count how many times this value to remove occur in quiz, and we assign it to the variable count underscore value, and then we run a for loop, this number of iterations, count value number of iterations. Okay, so with for I in range count value, you run quiz.remove the value that you want to remove. Okay, so let's run this and we get this. So this is just a generalized code than what we have seen here. Instead of writing quiz.remove this number of times, we run the iterations. Okay, now, so the remark, the above code work correctly, right? However, we can optimize this. So you notice that we execute quiz.count in line 3. So quiz.count is a built-in method. So if the built-in method is executed in such a way that it iterates through elements in quiz, and check if the element is equal to the target value. In our case, the target value is value to remove. If it is equal, then we add 1 to count, which is initialized to 0. So earlier on, when we talk about for loop accumulator to accumulate something, we also discussed how do we use for loop to count the occurrence of a number, occurrence of an element in a list. Okay, the idea is very straightforward. We iterate through the elements in the list that we want to count and check if each element is equal to the target value. In our case here, the target value is value to remove. If it is, we add 1 to count, where count was initialized to 0 before the for loop. Okay. Now, notice here that we count the number of elements. So in the end, we get an output, the number of elements in quiz here. Okay. And then in line 5, in line 4, we run another iteration, okay, to remove the value to remove the value to remove. Okay, so it appears to me that the second iteration which is in line 4, is a bit redundant because when you count, for example, when you execute count, if you execute in such a way that you already iterate through the elements, and you know that if it's equals to the target value, instead of add 1 to count, maybe we could have just removed it immediately. Okay, in the following way. So it seems redundant in the following way. Okay, when we iterate the elements in quiz, okay, and check if the element is value to count, the target element, value to remove, actually. Instead of add 1 to count, which is for the sole purpose of counting, where in our case, we just want to remove it, we could have removed it instead. Straight away. Okay. In this way, you only iterate the elements in quiz once. At every single iteration, you check if the elements is equal to value to remove. If it is, we don't count them. Instead, we remove it immediately. Okay. In this case, then when I remove it immediately, I don't need to another iteration, which is in line 4, to remove it. Okay. So in other words, I don't separate count with remove. I just run through the iteration once and I remove it. I don't have to count it. Okay. So can we do that? So let's do these strategies here. So attempt. So let's see, this is attempt 1. So attempt 1. So attempt 1. Okay. Attempt 1 is to count how many times it occurs and then remove this value to remove this number of times. Now attempt 2, okay, is to, when we iterate through the list, we check if it's equals to the value to remove, and instead of count how many times this value occur, we remove it straight away. Okay, so we iterate through the elements in quiz, and we check if the elements is equal to value to remove. Okay, and we remove it straight away. If it is, we remove it straight away. Okay, let's run this. Okay, so this is my original quiz. This is value to remove. So for every score in quiz, okay, if score is equals to value to remove, we'll remove the score. Okay, so let's run this. All right, so let's see the output. Okay, and we print the output. So we print quiz now. So you see here, I follow the strategy as I have mentioned. I reiterate through every element in quiz, and if it's equals to the value that I want to remove, I'm going to remove it. Okay, and then when at the end, I print out the quiz, I should expect that all value to remove has been removed. The value to remove is equal to 0. I should have the quiz have all the value zeros are removed. However, if you look at here, the output is such that 0 still occur. But our strategy is that if score is equals to the value to remove, we remove it. Why is 0 still occur in this list here? Remember, we were removing 0 here. So something is wrong is our code. Okay, so the above code does not work correctly. Okay, we need to investigate why. Okay. So 0 still occur in the final in quiz after the iteration, after the end of the iteration. So we need to investigate why. So to investigate why, we're gonna print out the values one by one. Okay, so for each of the iteration, we're gonna print out the score and the quiz. Okay, so for each iteration here, I check whether the score is equal to value to remove. If it is, I'm going to remove score. And for each iterations, I also print out the score and quiz. Now, the reason I print out quiz is because after I remove it, the value of quiz change. Okay, so let's investigate at each iterations how this change occur. So let's run this. Okay, so it say that the first iteration, the score is 5. Okay, the score is 5, and the quiz stay intact, just like the original quiz. Okay, there's no removal because 5 is not equal to 0. All right, then you go to the second iteration. Now score is equal to 0. Okay, score is 0, and you execute remove score. So you remove 1, 0. Okay, so now your list, the quiz now is shortened by 1 with the first occurrence of 0 is removed. All right, let's continue. Now the next value of quiz, it should be 0, but it says that the score is 5. So this is very strange because according to our original list, when we run score in quiz, the first score should be 5, the second score should be 0, the third score should have been 0, but it's 5. So what's happening here? Why is it not 0? Why is it 5? Okay, 0 here was removed. Okay, so the next element that we want to iterate with is supposed to be 0. There should be another 0 here, but it didn't give me 0, but rather it gave me 5, which means it skipped the 0 and instead go to 5. Now, why is that so? So let's see here. So from the above, print out of score and quiz at each iteration, it appears that the second 0 is skipped. We didn't test the second 0. We skip it straight, go to the 5. All right, there are 2 zeros here. It's test 0 is equal to 0, and it remove it. And there is this 0 here still remained in the quiz and wasn't removed because it wasn't examined. It wasn't examined. The next elements that is being examined is actually 5. Okay, so it appears that the second 0 is skipped, and the next iteration is skipped from the iteration. Okay, so why is that so? That is because, now this is because when running for loop in Python, okay, it uses internal counter to keep track of the element, to keep track of the next iterations. Okay, so this is the first iteration, 0, and then this is the second iteration, 1. This is the third iteration, which is 2. Okay, so index, this is 0, 1, 2. Internal counter start with 0. So at iteration with the internal counter 2, okay, the value of the quiz is 0, 1, 2, which is 5. So this 0 here was this 0 here because you remove the first 0. So this 0 will be moved forward to move forward. So this will become index 1, and index 2 will be this 5 here. So at iteration with internal counter 2, it will be this value of 5 here rather than this. Okay, so when the first 0 is removed, okay, the second 0 is moved up to index 1, which occur. So the first 0 is occur at index 1, is removed. The second 0 is moved up to index 1. Okay, so when the iteration runs for the third time, okay, the internal counter is 2. We start counting from 0. On the third iteration, the internal counter is 2. It attempts to access the value of quiz at index 2. And since quiz has changed, where now index 2 is of value 5. Okay, initially index 2 of quiz is of value 0, but now it's of value 5 because the value 0 is moved up to index 1. Okay, and the value 5 is moved up to index 2. Okay, so after you remove the first 0, subsequent values will move up by 1. All right, so the second 0 will move up to index 1, and the subsequent value, which is 5, is moved up to index 2. So when you run the third iterations, okay, the internal counter is 2. It attempts to access the value of quiz at index 2, which is now contains the value of 5. Okay, because value 5 is moved up to index 2, which is not the index, which is not the 0, because it has already moved to index 1. So essentially, and hence the second 0 in the original quiz is skipped. Okay, it has been skipped. Now, in that case, we didn't check whether this is equal to 0. We didn't check whether this is equal to 0, and hence we did not remove it. All right, and that's why this code here gave us the wrong answer. Okay, so we end. So our code gives incorrect output. Okay, so here, remark, avoid, we learned that we need to avoid mutating the list when iterating over the elements of the list. Okay, so when iterate over the list, over the elements in the list, we should never mutate the list in the iterations. Because when you do that, okay, as we have seen in this example, when you mutate the list, all right, the internal counter will not reflect it. It will still stay as the same. It will be, but your quiz value has changed. Some of the values have been moved up, for example, and you skip some of these values to test. All right. So the rule of thumb is when you want to use for loop to iterate over elements in the list, okay, you should never change the list. Mutating means to change the list. It can be removed or you can add value. You should also not add value into the list as well. Okay. Now, but how do we overcome this issue here? We still want to iterate the list once. Instead of counting it, when we encounter a value that we want to remove, we just remove it straight away. And we have seen that if we do that, we mutate the list and it gives us incorrect output. So it's this. We can, for example, option 2, instead, we're going to do attempt 2. So attempt 2 to fix this. So to fix this, we can create a copy of the list and iterate the duplicated list instead. Okay, and in the iterations, we remove the elements. On the original copy. Okay, so let's try this. So we're gonna create a new copy. Okay, so instead of iterating score in quiz, we're gonna create quiz copy. Okay, and we're gonna iterate this quiz copy here. Okay, if the score is equals to value to remove, you just remove the score. Okay, but you're iterating quiz copy, and what you remove, you do not remove quiz copy. Quiz copy is what you iterate with. We should not mutate it. You mutate by removing the score from quiz. Okay, quiz copy stay intact throughout the whole iteration. What you change is quiz. Okay, so now let's print quiz now. It removes all zeros in the quiz now. Okay, so we basically do the same strategy as before, but our strategy earlier on wouldn't work because our for loop, using the for loop in Python, we have an internal counter for which if you change the list itself, when you iterate, it will cause an issue. Now, to bypass this issue, we create a copy where we iterate with, but when we make changes, we change to the original list quiz. Okay, so in this case, we still iterate through every element in the quiz once, and instead of counting this, when we check whether it's equals to the value to remove, we don't count, rather we remove it immediately. Okay, in this case, we bypass the second iteration in our first attempt, where we do the count. So quiz.count, if we're gonna do some iterations here, when we count the number of times, we do some iterations and we add 1 to count. And then we have another iterations here to remove based on the number of count value, right? Now, in our case, we don't do that. We don't do count. Rather that we go through the list once and check whether it's equal to value to remove, and then you remove it straight away. So the above code works correctly. However, it requires us to create a new list called quiz copy, which of course occupy memory. Now, the reason we create this new list is to avoid the issue with the internal counter of for loop in Python. Okay, because when we change the quiz in our iterations, the internal counter do not keep track of these changes, and hence it gives us an issue. And to bypass the issue, we create a new copy, which occupy memory, which might not be what we want. And can we avoid creating a new copy? Now we can do so by not using for loop. If you recall, every for loop can be rewritten using while loop. So in while loop, there is no internal counter. Rather, we set the counter ourselves. We set the next element to test by ourselves. So we control the counter. Even though the quiz has changed in our iterations, we control the counter so that it doesn't skip any value. All right, so the idea is very simple. So we have a quiz, which is our original quiz, and this is the value that we want to remove. Okay, and we're gonna mimic exactly what we have here, but rather using for loop, we're gonna do while loop. Okay, so what is the conditions that we want to, so that it keep repeating? Okay, so if you remember, from for loop to while loop, we start with the index I equals to 0. Okay, so while I less than the length of quiz, all right, if quiz I is equals to the value to remove, all right, you remove that value. Okay. Okay. Now remember, we we keep track of the internal counter ourselves, okay? I equals to 0, I less than length of quiz, all right? If we don't change the value of I, if we don't update the value of I, we will get an infinite loop, okay? So for for loop to while loop, we usually just add I plus equals to 1, okay? However, remember in this case here, my quiz has changed, okay? Some elements has been removed, for example. And so if an element has been removed, the subsequent element will occupy the index of this value that has been removed. Okay, for example, in our case that we have seen earlier on here, okay, the first 0 is at index 1, and after this is removed, the second 0 will move up to index 1. The second 0 was at index 2, and now will be moved up to index 1. So when we remove an element from the quiz, okay, we don't change the value of I. All right, I will stay the same because we still need to test this value of I, which the value at this index of I will become the next element to test because the next element has moved up to this index. Okay. Only when there is no removal, when quiz I is not equal to value to remove, then we don't have to test this value again. We will go to the next value, which is at index I plus equals to 1. Okay, so let's try this. We see that all values of zeros are removed now. Okay, it didn't skip any value. It gives the same result as this. And previous one for which we run for loop using internal counter and change the quiz itself, it gives us an incorrect answer. And using a copy, we can remove the issue. It gives us correct answer. But if we don't want to spend memory on creating a new copy, we create our own loop by using while loop where we control the internal counter. Okay, so in this case, we control the internal counter. So when quiz I is equals to value to remove, we have to remove it. But when we remove it, the next value will occupy this space that has been removed. So the next index that I want to try is actually the same value of I. Okay, the same index I that I want to try. We shouldn't move or skip to the next one. But if quiz I is not equal to value to remove, then I will go to the next index. Okay, I don't test the same index anymore. Right, and that's all for today. Thank you.